Chapter 2, Lesson 6, Estimating with Percents. Please turn to page 137. So we have a guest today. Andrew is going to walk us through the real-world link.
Okay, real-world link. Josephina surveyed 298 students and found that 52% like scary movies. Estimate the number of students that like scary movies. Okay, so this first question is write the common percent. So 0, this being 100, and this is around half. So and half of 100 is 50, so that would be 50%. And half of 50 is 25, so it's 25%. And then 0, 25, 50, that would be 75%. So, second question is, what common percent is 52% close to? And that would be 50, because 52% here, is like literally right here. It's really close. So, it would be 50%. Round 298 to the nearest 100. 298 is closest to 300 because you go here, go that one, and you know that's over 5, so then you round it to 300. So, and then here, so 0 is 75. 75 times 2 is 150. So, and then you add that 75 again, that would be 225. So if you add 225 with that would be, if I'm right, 300.
Excellent. So then we know that 52% of 298 is close to how many students like scary movies?
So, it's closest to 150, so around 150.
Excellent, Andrew. Great job. Thanks for being part of my real-world link. So remember when I told you that estimating, and we put our little estimate in a cloud, how that will help you figure out what your answer is before you actually calculate it, so that when you come up with your answer, if your answer doesn't make sense, you can redo the problem based on what your estimate was. So again, we want a reasonable solution. All right, example number 1, estimate 47% of 692. So the first thing that we're going to do is round the 692 to 700. We want whole numbers. The whole point of estimation is that you can do it in your head. We're going to round 47% to 50%. That means we're going to cut 700 in half. If you think about $7, each person gets half, that would be $3.50. So we know that $3.50 is half of 700. This, again, is an estimate. We would put this answer in a cloud so that when we make our calculation, if our answer in our calculation, let's say, was 20, we know that our answer is incorrect because it needed to be around 350, so we would recalculate. All right, let's keep going. Okay, we have a similar problem to example number 2 that I had on our essentials. When I said 20% of 60 is what? So in this case, I have 60% of 27. Well, the first thing I'm going to do is make that 30. And then when I think about this, of means to multiply. So 0.6 times 30. If I think about it, I know that 18 is involved. And then I know there's a 0, but that 0 doesn't count because my answer has to be a little bit more than 50%. So we know that 50% of 30 is 15. Therefore, I know that 60% of 30 is 18. So again, I will take the 6 and the 3, I will multiply them together because there's 2 zeros. Here's 1 0, here's the other 0. They cancel out because 100% has 2 zeros. So these 2 zeros cancel out. So then all I have to do is go 3 times 6 and get my 18. I know this is a bit confusing, but after you work these problems, you will get it. This is how I do it in a department store. So go ahead and work on the dotted problems and come back. Pause the video. did you get what I got? I got 48 and 28. Now, again, I want to reiterate what I said. We can cross out 2 zeros based on 100%. How many zeros are in 100%? There are 2. So that's why I've got the cross-outs. And then all you have to do is multiply remaining numbers. Multiply remaining numbers. It's that simple. So after I crossed out the 0 and the 50 and the 0 and the 8, I have 5 times 8, which is 40. I cross out the 0 and the 20 and 0 and the 40. 2 times 4 is 8, and then 70, cross out the 0, 40, cross out the 0, 7 times 4 is 28. Turn the page. Alright, so now we have a real world problem. Polar bears can eat as much as 10% of their body weight in less than 1 hour. If an adult male polar bear weighs 715 pounds, about how much food can he eat in 1 hour? So I have 10% times, whoops, I don't want to use the X. I'm going to use the dot. Times, and I'm going to round that to 700. How many zeros can I cross out? 2. Excellent. 1, 2. Then that's 1 times 70. That is 70. Sorry, 1 times 70 is 70. So, he's going to eat 70. He's going to eat 70 pounds. That's a lot of food. All right, keep going. So in method 2, you're using the fractional part of 10%, which is 1/10. And again, when you think of a pie, if I divide my pie in 10 equal places, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I'm saying one of these. If the total is 700, then what times 10 gets me 700? 70 does. So again, think about what you are doing when you're computing. Okay, get the got it problem done. See you soon. Pause the video. Did you get what I got? I got about $75. And again, in my case, I had 30% and I had $238. I decided to round that to $250 because I know I can do quarters. I crossed out 2 zeros and then 3/4 is 75. So I said 75. Now, let's talk about this little squiggly thing. This little squiggly thing right here means approximately. Approximately. So when you're making an estimate, or you're saying something is about, you use the little squiggly symbol. Let's keep going. Okay, before we keep going, I do want to talk about one other thing. You might not have gotten 75. You might have gotten 60 if you rounded to 200. 60 is great. 75 is great. 80 is great. The number 2 or the number 5,000, those are bad. So when you're talking about estimation, you want to be in the ballpark. You're not going to get the same number I'm going to get if you round differently, but you should be in the same general area. Now we're going to do things based on 100, and we know percents are out of 100. So we've got 17% of 198. So again, if I make this 200, I can still keep the 17. I can make it 20. If I make it 20, then I'll cross out 2 zeros, and then it'd be 2 times 20, which is 40. That's my estimate in my cloud. Now, in this case, they kept the 17, and then they said 17 times they said 17 out of 100, which is 17, and then they doubled it. So 17 and 17 is 34. And again, 34 and 40 are close. I would not have kept it at 17%. I would have gone to 20%. Why? Because the whole point of this is that you're using mental math to estimate. You're not actually doing this with pen and paper. You're using your head to come up with your answer. So 20% of 200 is 40. That's a great estimate. So all of this is based on real world. So an airline records the snack orders of passengers. Last year, 9% of all passengers ordered ginger ale to drink. There are 408 passengers on the flight to Houston. About how many passengers does the airline expect to order ginger ale? So about how many? We know we're doing an estimate again. We have 9% of 408. Well, I'm going to change that 9% right off the bat to 10%, and I'm going to change that to 400. Then I'm going to cross out 2 zeros, which I would mentally do in my head, and then say 1 times 40 is 40. So I know that approximately 40 people would order ginger ale. Now again, they came up with 36 because they used 9. I used 10 because I want to do these in my head. I recommend you do powers of 10 so that you can do these quickly in your head. Let's do the got it. See you soon. So in E, 30% of 300 is 90. In F, 80% of 200 is 160. And then 25% of 1,000 is 250. So again, I use round numbers. I know that the book made them more precise, but my point is always using numbers you can do in your head. So do the guided practice, come back, and we'll talk about it some more. See you soon. Pause the video. Did you get what I got? For number 1, I got 10 because I went 20% of 50 is 10. 20% of 100 is 20. 60% of 20 is 12. And then number 4, half of $30 is 15. And then 30% of 500, cross out 2 zeros. That's 3 50s, and that's $150. So again, when an estimate is more useful than an exact number. When would we use an estimate? In retail, you're going to the store and you know that something is 30% off and you want to know, do I have enough money? So you make a rough guess to determine whether or not you're even in the ballpark to pick up that dress or not. So again, when we talk about these, the answers that they got in the book under guided practice are different than the answers that I got. Why? Because they were more exact in their rounding. I don't think that's necessary. I want to be in the ballpark so that when I get my true answer and I compare it to my estimate, they look similar. Okay, see you in class. Bye.